Hello class, this week we're talking about frequency distributions and I want to walk through how to create a frequency distribution. Um, Over here you'll see this is an example from the PowerPoint and I just have this up here as reference for what your frequency distribution should look like. Over here we have some data and we are going to populate this grid right here to make a frequency distribution. I've separated the class here is just a range of numbers and I've just put those in two different columns, the lower number and the upper number, and you'll see why later. So I'm going to go through this twice. First I'm going to do it manually, if you will, and then I'm going to walk through the same frequency distribution using Excel and what Excel can do for us. So these are our numbers. And what's important when you're creating a frequency distribution is that you have to have your numbers in order. And the first thing we have to do is establish a class width. Now, this is all dependent on the number of classes. Each of these rows here with a class, this is the number of classes. So in this example, there's 5. And we too are going to create a frequency distribution with 5 classes. And that information would be given to you. I will tell you, if I'm asking you to create one, how many classes to use. So to create the class width, first we need to know the range. And the range is just our highest number or a maximum number minus our lowest number. So 64 minus 6 is 58. And then our class width is our range divided by the number of classes. So it's going to be 58 divided by 5. And we will use our calculator. Oopsie daisy, sorry. And that equals 11.6. When you're determining your class width, always round up. So if this were 11.1, we would still make it 12. If this turned out to be 11, we would still make it 12. Even in a whole number, we are going to round up to the next whole number. So our class width is going to be 12. We use that class width to help us create our classes. Our lower limit on our first class is just our minimum number, which is 6. And then we take that class width and we add it to the 6 and continue on to create all the other lower limits. So 12 plus 6 is 18. We add 12 to 18, we get 30. We add 12 to 30 and we get 42. And we add 12 to 42 and that is 54. And then our upper limits, on the first one, we'll just take the number that's one less than this because we're creating classes where we can put our data into. So the next class begins with 18, so this class has to end with 17. Once you've established this number, again, you can just add your class width to it. 17 plus 12 is 29, and as you'll see, that 29 is one less than 30. 29 plus 12 is 41, and as you can see, the 41 is just one less than the 42. And plus 12 is 53, which is one less than 54. And then 53 plus 12 is 65. The frequency is just a laborious task. You just have to count the entries in your data set that fall within this range. So between 16 and 17, we have 1, 2, 3, 4, 5, 6, 7. We have 7 numbers. That's all the frequency is. It's how many numbers are in that range. 18 to 29. 1, 2, 3, 4. And then we have 30 to 41. 1, 2, 3, 4. And then we have 42 to 53 is 2. And then 54 to 65 is just 1. And Keep in mind, it's possible to have a frequency of 0. If there's a big gap in your numbers, it's possible that when you're figuring out your frequency for each of these classes, that it is 0. And how many numbers do we have? I'm just going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18. We have 18 numbers. When I add up my frequencies, it should equal 18. If it doesn't, then you know you've made a mistake. And if I add this up, I do get 18, so we're good. 8 and 7 is 15, 16, 17, 18. The midpoint is just the lower plus the upper range of your class limits divided by 2. So let's do it over here. I'm going to do 6 plus 17 is 23, and then I'm going to divide that by 2, and that's 11.5. Now, to make your life easier when establishing the midpoints, once you have the first one, again, all you have to do is add the width to it. So I can say 11.5 plus 12 is 23.5. I can add 12 to that, and I have 35.5. I can add 12 to that, and I get 47.5. And I can add 12 to that, and I have 59.5. Your relative frequency is your frequency, that's this column right here, divided by your total number, which is 18. We have 18 numbers. So on each of these, each row, I'm going to divide my frequency by the total, which is 18. So 7 divided by 18 equals, we're going to round 0.39, and then 4 divided by 18 is 0.22, and that's going to be the same for this next row because the frequency is 4, 0.22, and now we have 2 divided by 18, which is 0.11, and then 1 divided by 18. And that's 0.06 if we round. This is the piece of the pie each of these frequencies have. If we add up our relative frequencies, we should always get 1. If not, then that's a clue to us that we made a mistake somewhere. So if I add up 0.39 plus 0.22 plus 0.22 plus 0.11 plus 0.06, I get 1. And that's what I should always get when I total up my relative frequencies. Cumulative frequency is exactly what it says. You start with your first frequency, and then you just accumulate your frequencies. So we start with 7, we add 4 for 11, add 4 more for 15, now we're adding 2 over here, 17, and now we're adding 1, which is 18. Our last cumulative frequency will always be our total frequency. And the class boundaries we create so that when we create a histogram, our bars are touching. We want to make sure that we've covered every number on the number line. So we just subtract 0.5 from our lower limit and we add 0.5 to our upper limit. So the class boundary is just 5.5, and then we go to 17.5. In the next row, we just go down a half, so it's 17.5, and we go up a half to 29.5. And that's what we do in every row. 41.5, and then 41.5 to 53.5, and then 53.5 to 65.5. And you can see by doing this, we've accounted for every number on the number line, if you will. We haven't left anything unaccounted for. So this is a completed frequency distribution with